So thank you for coming to Kotlinify or Gradle. In this talk, we're going to check and see where Kotlin fits into Gradle. Would it be in Gradle Plugins or in the Gradle DSL? So first, a little presentation about myself. I'm an Android developer at Houzz. And I also organize and speak at a local Kotlin meetup group called KOTLIN-DSL in Tel Aviv. And I love to build tools. I think it's really satisfying to build tools for clients, but I enjoy much more to build tools for us because it helps us to be more productive. So that's how I got into the Gradle plugin side. And so today, as I said, we're going to talk about Gradle plugins and the Gradle Kotlin-DSL. So for the Gradle plugins, who here developed one already? Okay, not everyone. So I hope it will still be interesting for you. For others, we're going to develop a small plugin here together. So what is Gradle first? It's a build system. We build Android with that. And it's JVM-based, means it's written in Java. It defines tasks inside a project. We get all project is represented by a class called project, one instance of that. And we create tasks in it. Plugins actually are sets of tasks that comes bundled up with Gradle or from other companies and bring a set of tasks inside your project. So with that, we can build Java, Kotlin, of course, Android, but also iOS and .NET, which was quite surprising to find, but yes, people use Gradle also for other projects that are not JVM-based. So some interesting plugins. Why do we want to build plugins? Because, for instance, Android build their own plugin on top of Gradle, so we can build our apps with Gradle. We have, of course, the Kotlin Gradle plugins to compile Kotlin code and add it to our project. There's also other random projects that are really interesting. For instance, this one, Ribbonizer plugin. It's the one that lets you automatically add a ribbon on your icon, so you have a debug version and a release version. So you can see on the icon which one you're working on. There's a plugin to publish to Google Play, interesting, and etc. You can find there's a ton of Gradle plugins out there. So building a Gradle plugin, we're gonna make one right now. As a small example, we're gonna look into all the comments that have a to-do keyword, and we want to print them out. Why would we want to do that? For instance, we could say, okay, our project should not have any to-do ever, which is a dream, I know. But we want to print that out when we build a project and send an email to all the team so we know what to-do lines are left and eliminate those. So for that, we're going to find all the source files in our project. Would it be Java, Kotlin, and many variants. And we're going to look at all the lines that starts with to-do and the command line. And of course, as I said before, we're going to look for that in every variant because we can have we have the main. This is the basic variant we have. We can have one as much as you want actually. We have already two additional, which is debug and release, and you can have the same class in different variants that are completely implemented in a completely different way. So you can have a hello manager, let's say in debug, that prints out something, and in release it is the same function writes out completely a different thing. So for some context in this presentation, we're going to work on a Gradle plugin in IntelliJ called Android To-Do's Gradle plugin, which I put here the GitHub link so you can look into the source code. And in parallel, we're going to work on an Android app that is just going to be some code to run this Gradle plugin that we're going to write, so we can test it. So to use a Gradle plugin, we're quite used to see that kind of code. We're bringing some plugins from repositories, Maven repositories. We're going to import them into our class path, and we're going to apply them. So a little word about where are those plugins. When we have our computer and we as we want a plugin and we add a repository, Gradle will download this jar. It's basically a jar, and import it locally. It can come from many places, like Maven Central, G-Center, and finally Google made their own repository for Android dependencies, which is awesome. We also have a possibility to work with Maven local. This is what I'm going to do here. I'm going to build a Gradle plugin, deploy it locally, and use it via Maven local. There's another option called build source, which is a folder which can contain Gradle code that Gradle will build automatically every time. It's good for small script that extends your project, but I don't like to use that for Gradle plugins because first I intend to reuse a Gradle plugin, so I want it already packaged as a library, as an external dependency. And I think in build source, things can become a little bit messy if you add more than one plugin. So a little word about the Gradle API itself. So we have a common language here. We talk about a project. As I said, it's the main thing that the Gradle manages. We have other classes like repositories for the repositories. And what we're going to take a focused look on is the task interface, because we're going to create a task to print our to-dos for debug and for release. So to create a Gradle plugin, we're going to just create a Gradle Kotlin project. We're going to update some dependency here just to be on page. I know 4.7 already went out. Those slides are already a little bit outdated, but things are still relevant for that. We're going to add dependencies to two main things. First, in our project, we're developing a Gradle plugin, so we need the Gradle API. We have Gradle itself brings a utility function called Gradle API, which we can use to import it. And because we're developing a Gradle plugin for Android, we want to depend and have the API of the Android Gradle plugin. And we don't want to have it in our code. We just want to have it referenced. So compile only is like provided. And from then on, we have all the APIs of Android, of the Android Gradle plugin. So those two are the main dependencies that we need in a project to build Android Gradle plugins. So we're going to first name our plugin. We're going to add some extension with with a plugin ID, artifact, and version to deploy for Maven local. We're going to be able to deploy locally by using a Gradle plugin called Maven publish, which gives us this little API to define what we're going to publish to Maven. And just having those gives us those tasks in our list of tasks in Gradle, and we can, as you can see, publish to Maven local. When we double click on that, it gets pushed to our local Maven, and we can actually switch to our Android app and apply, depend on this new plugin we just published to Maven and apply it. So here we're gonna define the dependency to our plugin. You see the last line here. And in our build the Gradle, we're going to do apply of the plugin. Now we're going to see what this apply really means. So as I said, we defined a repository Maven local, important, and the class path to the plugin. So this apply is actually the Gradle entry point to the project. So on the Android app, we're going to have this line, apply plugin, and this name that is completely up to you. And on the Gradle plugin, we're going to have a special file of the same name, .properties. And those two need to match 100%. That's how Gradle looks into the jar you depend on, and will find the plugin itself, the class that will run, the entry point, the main function, let's say, of the Gradle plugin. So this file itself contains one line, implementation class and the path, the complete path to the class. Here I call it to-dos plugin because we're doing a plugin to do this. And this class, we're going to write it. Finally, we're going to see some Kotlin code by extending, implementing a plugin project and overriding the function apply. Here I just add a to-do function to remind us that we still didn't implement anything. And when we run that, we actually get an error. So why an error? Because to-do is a function that returns nothing. Basically, it throws an exception. It throws the message we're sending to. So let's go back to our plugin class, and we'll implement it now. We'll really write the code to find all our files, or source files. So first, we're going to look into this is a few lines that you'll find in every Gradle plugin that is made for Android, because we want to be sure that we're on a Android app project. So we're going to check if we're in an app or in a library, and if not, we're going to throw an exception. So just to remind you that this dependency is possible. To do that, it's possible only because we depend on the Android Gradle plugin itself. And then we have those imports that we can check if we are in the context of a plugin or a library plugin. After that, we're going to look for all the variants in the app. The APIs are different if you're an app, a plugin, or a library plugin. So we need to check one or the other by taking the extension themselves by type and then getting the right attribute on them. So application variants for app and library variants for library. After that, now that we have all our variants, we're gonna iterate on them. And for each of them, I just wanna, because I'm developing that right now, I just wanna print out what it shows up, just to see if I'm going on the right way. So by doing a flat map and looking into every Java directories and printing it for each of them, I get this result. So I do get all the source folders where I'm supposed to look for my to-dos lines. So after this, because we wanna now gather those and send them to a task. We wanna create a task that will give us a way to print those to-dos for every variant. We're going to create those. First, we're going to run, again, on all the variants. We're going to define the folders, and this is the same as previously. We do a flat map on the source set of the variants, and we look at every Java directory. Java meaning Java or Kotlin. It's a source set. It's not per language. And we define a task name. The task name is what we're going to run. So when you do a Gradle W and name of the task, that's how it's made. You generate a task name, and then you create a task with it. So here we're going to create a task name print, the variant name, debug, release, and to do. So we will have two tasks. If we have debug and release, we'll have print, debug, to do, print, release, to do. And then we're going to create our tasks. This is the part where we pass the folders that we gather for every variant to the class task. We're going to see that in a minute. And just a little word about those two lines. They're really nice. You can define for every task a group and a description, which give you a nice separation like this, where you have a group to-dos. This is the folder, and my two tasks are underneath. So just to clarify here, we have three phases in Gradle project. We have the initialization, the dependencies, and all that stuff. We have the configuration. What we're doing now, we're configuring the plugin to add tasks to a project. So we're not running any code. We're just configuring. And execution is when we're going to really run the tasks. So now we're in the configuration phase. It's important because this separation gives you a good idea, and you can better develop Gradle plugins, because sometimes you expect things to print out or not, and it's usually because you're in configuration phase and not in the execution phase. So we talked about creating our tasks. Let's see now what is this real class, the to-do task class. So it's an open class. It needs to be open because you know in Kotlin every class is final by default, contrary to Java, and we need to open it because Gradle, depending on what you put in a Gradle in the build.gradle file, will create a new task by reflection. So we need an empty constructor and an open class. And then we're going to have a function called run. The name is not important. The important thing is that we have a notation task action. This is the main code of the task. And here we're going to go, we received all the folders, as we saw previously. And we're going to go through every folder. We're going to walk in it recursively. This function walk gives us all the folders and the files under the current folder we're on. We're going to filter it on only the files. I'm not interested in folders, I just want files. For each file, we're going to read every line. We're going to go through them with an index. It's important for our case. And then if the line starts by //to-do, we're going to print it with index +1. This gives us a really nice way to print it. So the moment I'm going to double click on my task or run it by command line and execute it, I'm going to have something like that. I hope you can see something. Here I have two lines with some to-dos. And by putting the index number and the whole name of the path, those are actually clickable. This is made automatically by IntelliJ. So you can click on it and you get to the line. So that's how also the Android Gradle plugins brings us to the right line when there's an error. Okay, so this is running the plugin for the variant debug. If I run it for release, I have here some different comments in different folders, and I see that everything works. I get all my lines. So this is sweet. We saw what is a project. We saw what is a task. Now there's one last part in a Gradle plugin that we didn't talk about. It is parameters, parameters. So you usually, when you incorporate a Gradle plugin, you have also parameters that you can give to the plugin to work in a certain way. So this is called an extension. And to define, we're going to first use that extension because I want in my Android app to be able to ask lines not only to do, but also what the hell or whatever. And so to be able to do that, we're putting to do and we open brackets, and then we put the parameters. We used to do that for every plugin. And how do we do that? We write our own extension class. It's again an open class for Gradle to implement it and instantiate it. We're going to have here property keywords, the keywords that we want to pass. It's a list. And this is, in Gradle, a really good place to put validation. And here, I don't want this thing to be null or an array that is empty or one of the words to be empty because then I'm going to print every line. It doesn't make sense. So here I'm validating, and only if all the validation passes, the else part here, I'm going to assign this value to the field. Field is the keywords. You cannot write here else keywords equals value. Field represents the field you're in a setter of a property in Kotlin. So great, we get our extension. We want to be able to use it, so in our project, in our plugin, we're going to use a project.extension.create to do, and then we're going to give that class. And when we do that, we can actually add now the to-dos with the brackets in our Gradle plugin file. And this is the apply function. In our tasks itself, we want to use those keywords now. So we're going to get them from, first we're going to find the extension itself with this API, find by type. We're going to look for the keywords, which are just an attribute, but they can be null. So in case someone gives keywords that are null, I want to have at least to do, so I have a default value of to do. And we change the main code of the task to go through every line. Now I need to separate the backslash and the keywords, and I do an intersection between the keywords that are send, and all the words of a line. So this gives me an array of the common words in a line, and if it's not empty, meaning there's a comment there, I can print it. And when we can now, back in our Android app, define it, and when we run it, we can have different comments with different keywords now. So, to recap this part, we built a Gradle plugin, awesome. We created a task for Android build variants, which is important in Android because we can have different source sets for every variant. And we used an extension to add parameters to this Gradle plugin. Cool. So after we did that, this is one part that I wanted to show where Kotlin has its place. It's, again, a Gradle plugin is a Java project with some properties file to indicate where the plugin class is. And we can, of course, use any libraries, any feature that Kotlin brings here, with the big coroutines and all others to do whatever we want there. So the other part that we can use Kotlin in Gradle is the KOTLIN-DSL. So first, what is a DSL? DSL is a domain-specific language. It's opposed to a general purpose programming language, which is, C, Java, Kotlin itself. A domain-specific language is made to be simple and to describe something. For instance, I want us to create a little DSL just for understanding what it is. So we're going to create, we have here a few models. Color, we're going to create a DSL to describe a car, a vehicle, more correctly. So we're going to have colors for the wheels, and a vehicle has wheels and some type of engine. So the imperative way of creating objects is to call, to instantiate a new object with the parameters like we used to do everywhere. We can print it, and here is what will be printed because this one is a data class, has a two-string automatically generated. So the DSL version of this would be something like this, where I declare a vehicle and I can set every field, and it's much easier to read. In this case, it's a little bit stupid to do a DSL for this API. It has no value. But think about the library that you really want to configure with lots of options, lots of underparts. You don't want to start creating objects for every one of them. You want to be able to declare it. So this is a really nice way and a clean way to do it. So this is a DSL. To create that implementation here, we'll look first at vehicle. What is vehicle in this context? We saw we have a vehicle class. That's fine. But vehicle here is not an instantiation of that object. It's something else. This something else is a function. And this function, and the whole secret of a DSL is that it uses lambdas with receivers. So what is a receiver? A receiver is, what is a lambda with receiver? It's a lambda that gets this at the context of the lambda. That's it. It took me a long time to understand that, frankly, but it's quite simple. So here, if we have vehicle, we can do engine equals V8 because engine is an attribute of a vehicle, and this function returns an object, vehicle itself, with some code applied to it. So because it's a lambda with receiver and I have this, I said, in the lambda, I can do this.engine. This is exactly the same. And I really like that sometimes to this dot to be sure where I am and what are my capabilities inside the lambda with the receiver. And a little word about how this function is implemented here. We can see that the vehicle.apply block here is using the apply function to apply the lambda with receiver on a vehicle. And the equivalent to that apply function, if we were write it, is to create a new vehicle, call the lambda with receiver on this vehicle, and return it. That's all. And mainly, DSL is made of a lot of functions like that. To add to continue, so yeah, this is the implementation itself. So now the wheels part. Wheels here is an attribute, but here we want to return first an object wheels implemented with the things inside it. So here there's a little bit of inside-out functions, but this is implemented with another lambda with receiver, which is itself an extension function of vehicle. So this is the way we can add DSLs on APIs we don't implement. So we can do whatever DSL we want on any library if we find it difficult to use. And the first disk that we see here that is on the wheels is actually the extension function on the object vehicle. Remember, the vehicle bracket opens up there is a vehicle itself, an instance. So this is that object. And the second vehicle dot parentheses is, and those two disks are the lambda with the receiver of the wheels function. Okay, a little bit of mixing extension functions in lambda with receivers, but we get to the point. So just to clarify, a lambda with receiver, it's a lambda with inside this. That's it. I just hope that I managed to simplify it for you guys. So what is the Gradle DSL on top of that? It's this API that we saw previously with a set of extension functions and lambda with receivers and an IntelliJ plugin / extension that understands .kts files. So KTS files are Kotlin script files. It's what we replace build.gradle with. We just add the extension .kts, and Android Studio will understand that we intend to write Gradle DSL code to build our project, but in Kotlin. So, yeah, a little PS here when you convert things to Kotlin, with Git especially. I prefer to do it in 2 phases. I know it's not the best because there's a middle phase here that is not really nice, but I would first rename the file, then commit it locally, then modify its content to be Kotlin and not Java or Groovy in our case, and then commit and push. Because if we're not doing that in 2 phases, Kotlin, Gradle, not Gradle, Git, Git doesn't understand that we changed the same file. And then we lose our history, our log history, which is really annoying. So by doing it that way, we can keep our history, and still have our changes made. So the build.gradle will be renamed build.gradle.kts, committed. Then we're going to modify the content and then commit and push. So I think this is a nice way to keep the log here. So converting the plugin itself. The Kotlin DSL is in version 0.16.3, so it's quite new, although it was announced, I think, last year. They're working really, really hard on that. There's already a lot done, but it's not easy to start on. We need to be honest here. There's no automatic converter like we have for Java classes. So the state of your project while you're converting it is all red. You need to refresh, you need to close and open IntelliJ or Android Studio a few times to make it work. And it's a little bit annoying, but once you do it, it's really nice because you get the advantages of a statically compiled language in your Gradle description. So when we have this block of build script, I discovered that actually we can change it to plugins. Plugins is actually also something that exists on Groovy, which I didn't know. But it makes things much lighter. Here, the plugins are defined and actually in a Maven repository of Gradle and are imported directly and applied. So this is the change from before and after. While not using exactly the same function, I agree. For the others, it's going to be more straightforward. Here, I forgot to tell you, I'm converting the Gradle plugin that we developed to print the to-do list first, and then we'll switch to the Android app also. So we can see both sides. So defining options on tasks. This is the Groovy version. The Kotlin version will be like this with type, and then we can define the attributes inside of them. So a little bit more verbose, I agree. Another thing, defining tasks. So before we can just write task and then short jar because the type inside in parameters and then go on. On Kotlin, we're gonna use also the task, another like a Kotlin function called task, when we need to define the generic type, because Groovy is much more dynamic. It manages to find all those things automatically. Here we have a compiler, so we do need to describe a little bit more things. Although I think it's good because then it makes it more understandable to read it. There's less magic implied. So the tasks before on Groovy, and now generating tasks with Kotlin in in Gradle with the KOTLIN-DSL. Apart, where we define variables for all the projects, ext, which is a general extension. We're actually going to have to set values now because ext is kind of a map, and we have a set function there. We cannot define attributes on it. So we're going to use set to set all our values. And here we published before our Gradle plugin to Maven Local. And this part becomes something like this, where we have a create function. This is extension function on publications. We give a generic, we give a name, and we define every attribute with equals, or we call functions with parameters. Here you see the usage of the ext of the project. We can do .get also. But this is a shortcut with the operators. So now, after we converted the build Gradle file over Gradle plugin, we're going to convert the build Gradle file over Android app. So this big chunk of code that we used to is not changing much, as you can see here. This is the Kotlin part, because you can't, in Kotlin, and this is something I was surprised of, you can define an infix function, which is a function you don't need to give parentheses on an attribute of a class. So you can, so instead of writing application ID, let's say if I have an infix function application ID, I could do this application ID and a string, but it's useless because we have to put this keyword again. So I don't think anyone implement that on object, on attributes, so we're just going to have to do assignment and call functions, like here. Signing configs and build types change a little bit. This is the Groovy version again, and now the Kotlin version, where we don't have a way to call a string directly, because if we wanted to have that in Kotlin, we'll have to write debug somewhere. It should be a function. And you want to be able to define it dynamically. So here it goes to become function. So get by name will be that function that we're going to use to find or signing config of debug. Here we assign store files. And same goes for build types. There's also a function called create to create new ones. Instead of, so we don't have to just write the name of the build type like in Groovy. We have to use create or get by name to find them or to create them. And source set, same thing, get by name for each of them. Here I left the diff, by the way, just to show you that we're still in a Lambda with receiver. And dependencies, again, don't change much. Same story with not having infix functions. And we just call them as functions. Using our Gradle plugin, we had these to-dos with an array. We can have, it's called array literals, I think, in general, and Groovy implements them. In Kotlin, we don't have them, so we have to do a list of. I hope they will implement that, so our code will stay exactly the same, and it's, I think, more readable, but this is a big debate into the Android Kotlin development community, and they want it, they don't want it. Whatever. For now, we have the list function. So to recap the KOTLIN-DSL, we converted from Groovy to Kotlin. Now we have 100% Kotlin projects, both our Android app and our Kotlin in our Gradle plugin. It's not easy to switch. As I said, the state of the IDE is refreshes itself while we change it, so it's not yet there. Also, the version of the KOTLIN-DSL is really young, 0.16.3. I would use it. I think now that I learned that thing, I will use it in my project on the side, not at work yet, not in production, because everything is still written and defined for Groovy for now, all the documentation that we have online. But it's coming along nicely. What is good is that it's Kotlin, so it's fun. And that, I think, is a good argument to start looking at it, not use it still in production, but give it a try on your side project. So for the whole thing, I think I put here a few links, the two projects themselves, some readings on KOTLIN-DSL, and two good books on Kotlin and Gradle, both for mining, that are really interesting if you want to look more into the subject themselves. They don't talk about the KOTLIN-DSL still, but I guess someone will write a book or a part of a book on it soon. So thank you. If you have any questions, I'm here. We're doing the time.
Hi.
Hello.
So you talked about two things, writing plugins and converting your Gradle files to Kotlin.
Yeah.
I have a question. Do you have any tips if you want to write your plugins in Kotlin and then use them in a classic Gradle file still written in Groovy? Because I noticed, for example, you talked about using extension functions in your plugin, but if I remember correctly, then when you're trying to use them in Kotlin, in Groovy within your Gradle file, it becomes kind of problematic. So have you tried doing that, like writing a complete plugin in Kotlin and then using it in a Groovy Gradle file?
So that's what we did at the beginning. We wrote the plugin in Kotlin itself. We deployed it as a jar, which gets compiled, to bytecode, and then we used it as the extension itself, the to-dos one with the keywords parameter, in Groovy first. So yes, it's completely doable.
Okay, great, thank you.
Yes.
Sorry for my English. Do we have to still use extension from Groovy if we only use Kotlin in, for example, your build.gradle you created a DSL from Kotlin.
Mm-hmm.
Can you use this DSL directly from the build.gradle?
I guess if you import it as a dependency, you could use it, yes. I think it's doable.
So
I didn't do that, but I think it's doable. Actually, what I didn't show here, and I saw in a few examples, is a Gradle plugin can also depend on the KOTLIN-DSL itself and then enjoys all the functions that are there on top of Gradle for Kotlin. So you can iterate these in other ways on the variant, on the variants of your project and stuff like that. So yes.
Okay. Thanks.
Okay. No more questions. Thank you very much.